11 students. We are working in 5.8 and we're going to work on phase shift today. We're going to do this video in two parts with the phase shift, the work on paper in the first part, and then we're going to do some modeling in the second part. No, I'm not going to get up and model a dress, but we're going to use some real life problems to help us figure out how this works in real life. All right, so let's go from right here. Phase shift, sinusoidal, curve, I forget the words, curve fitting. We're interested in this form, y equals a, where a is the amplitude, sine or cosine, omega x, so this little w symbol is the omega x minus the phi plus b. Now the A is the amplitude, the B on the outside is your up and down on the y-axis, and it goes with the sign. So if it's plus B, you're moving up B units. If it's minus B, you're moving down B units. The phi and, the omega and the phi have to do with the period and the phase shift. So the period, which how often does this transformed sine function repeat itself? Normally, sine repeats every 2 pi. But now our new period will be 2 pi divided by whatever the omega is. 2 pi divided by omega will be our new period for our transformed sine function. Phase shift is how much you move left or right. Okay, and that's going to be phi divided by the omega. So let's just jump right in here. And we're going to do y equals 3 sine 2x minus pi. All right, so let's go over here and switch over to my stuff that I've already worked out. So here's our basic model. And we could put the plus b out here, which is going to be moving up or down the y-axis. But our first one is not moving up or down the y-axis, okay? No b value out here. But we are stretching it an amplitude of 3. If we do our period is going to be 2 pi divided by the omega 2. So we end up with 2 pi over 2. So now we have a period of pi. And we have a phase shift of omega divided by, phi divided by omega, pi divided by 2. Pi divided by 2. It'll be negative. And so remember, it goes in the opposite of what direction. So you think it might be negative pi over 2. You think it might be going left, but it's actually going right. All right, so let's think about it. Amplitude. Normally, what is the normal range of a sine function? Normal range of a sine function, remember, is -1, the y's less than or equal to 1, less than or equal to positive. That's your normal range. Okay, but we're stretching it up and down by a factor of 3. So our range is going to be -3 less than or equal to y less than or equal to positive 3. And we're not shifting it up or down, we're just stretching it, okay? Now your domain for all signs, always going to be all real numbers, okay? Now we are, normally your sine repeats every 2 pi. We are repeating every 1 pi, okay? We're repeating every 1 pi. But if I sketch me out a little graph here, repeating every 1 pi, normally, you would say for sine, you're going to start at 0. Okay, so we'll mark our 0. And you're going to go out here to maybe 2 pi. Okay, so let's do our 2 pi. This would be our 1 pi. This would be our pi over 2. Let's see, pi over 2. 2 pi over 2, and this would be 3 pi over 2. Are you getting more familiar at counting up by fractions, pi fractions, radians? All right, so normally we would be from 0 up to 1, but now instead of 1, we're going up to 3, and we're going down to -3. But normally we would start at 0, go up, down, bottom, and back. Okay, but we're not. We are squeezing in, and we're just going to be here between 0 and pi. We're going to repeat every pi units. However, we're also shifting over pi over 2. So instead of starting at 0, I'm going to start at pi over 2. And I'm going to go in pi units from there. So pi units from, if I pick it up and shift it over, pi units from there is going to go all the way to 3 pi over 2. Okay. Now, I need 5 places in between this. All right, so this, when do I get up to here? This is going to be when I get back down to 0. But what is this value up here in between pi over 2 and pi? Okay, what is that? Well, do you know how to figure that out? You add them up and divide by 2. And let's say you hate calculate, excuse me, let's say you hate fractions. Well, that's why I like for you to have this fraction, this calculator. So we need to know, what is pi over 2 plus pi divided by 2? What's this middle point here? All right, well, just forget the pi part for the moment. Let's just take the fraction parts. This is 1/2, basically 1/2 plus 1, okay? So 1/2 plus 1, I'm going to divide it by 2, but I want it in fraction form, so math frac, that's 3 pi over 4 there, okay? And then if I want to know what is this part in between pi and 3 pi over 2, then I'm going to take the fraction part, 1 plus 3 over 2, 1 plus 3 over 2, divide it by 2, and switch it back to a fraction. That is 5 pi over 4. Okay, so these are our magic numbers now. Pi over 2, 3 pi over 4, pi, and then we're back down the -3 there, and then back down there, and we are able to sketch out our graph. I'm terrible at sketching. I'm a math person, not an artist. And that's just these 4 major points, but this thing is going to continue on. So you can, draw your arrows there. That's not all that it's doing. It continues on. All right, now would you like to see a little bit better picture in your PowerPoint slides, of course, are a little bit nicer than my drawing. So let's see how they drew it out. All right, so this was the key portion that they got with those 4 main values. And then you could stretch it out. It goes on infinitely in both directions. All right, Tay. All right, let's do one more. How about y equals 4 cosine? Now we're doing cosine 2x plus 3 pi. Now we have -1, so we're going to move this guy down the y-axis by 1. Go back over here, and let's just kind of analyze this a little bit. Got it written down here. So 4 is the amplitude. I got a vertical shift down 1. The period is going to be 2 pi divided by the omega, the 2. So 2 pi over 2 is pi. So again, I've got a period of pi. And now my phase shift is going to be the phi divided by the omega. However, you might notice that instead of a negative, I have a positive. So now this is not going to shift right. This is going to shift in the opposite that we think it would. It's going to shift left. All right, and now we have a vertical shift down 1. Okay, so normally your cosine, what your normal range of your cosine would be -1, less than or equal to y, less than or equal to 1. Cosine normally goes on the range. Talk about the range, the y values. Normally goes from -1 to 1. But we are amplifying, we're stretching ours by amplitude of 4. So we're going to go from -4 all the way up to +4, except that we're going to shift the whole guy down 1. So I would have started at -4, but you shift that down 1, you're at -5. And then I should have ended at +4, but if you shift that down 1, I'm going to end at +3. So now we at least on our cosine, okay. All right, remember that your normal cosine, you got 0 over here and 2 pi over here. Normal cosine, that would be pi. Here would be pi over 2, and here would be 3 pi over 2. So normal cosine is going to go up. It's going to start at 1, right? Start at 1. So 1, I'll do it with a little light pencil. It's normally going to go like this. Yeah. 2. All right, that's what normal cosine is going to do. That's normal cosine before any stretches. Okay, Ours, instead of -1 to 1, ours is going to go all the way down to -5. So I'm going to draw down here, -5, and all the way up to +3. So we got a much higher range, okay? It normally starts at 0. I am shifting it left 3 pi over 2, okay? Period of pi. So normally, it starts out like this, but ours is squeezed in. So we got a period of pi now, but we're going to take this period of pi and we're going to flip it, shift it left 3 pi over 2, which is actually, oh, I didn't even leave myself enough. Did not even leave myself enough to be on scale with this guy, but we'll say he's -3 pi over 2 is way over here. All right, so -3 pi over 2, negative pi over 2. Okay. So now my first, instead of being at 1, was going to be at 3, but instead of being at 0, now it's going to be here. Okay. It's going to go pi units. So that would just be between here and here. Okay. From -3 pi over 2 to negative pi over 2 would be pi units. So I need to figure out what that point is. That's where you come down. This one, you're going to go all the way down to the -5. Here, you're going to be back there, and then you're going to be back up to 3 here at negative pi over 2. Okay, so we've got, and of course, this goes on infinitely. This is just kind of our basic. So you can, not do your little arrows, so you're continuing on. All right, let's look again at how that looks in our book, because they're a better drawer than I am, but I want you also to be able to sketch this out yourself. All right, so you see how theirs is there. All right, but it would continue on. It would continue on. And and we've already shifted ours down 1. All right, so there's a summary of that. I don't know if you want to pause that and write it down, or if my working through it myself is sufficient for you. All right, we'll come back in a second video and we'll work with doing some real life modeling of this stuff. All right, see you in a bit.